Welcome to the Slop Temple. We pray this video helps.
You start by locking the problem boundaries. State inputs, outputs, and limits clearly. Once done, pick candidate algorithms and data structures that match those constraints and sketch a trivial example with expected output to test thinking. You should write a short, concrete test case now, run it mentally, and note edge cases. This prevents wasted design. Make sure to record complexity goals, what runtime and memory you must achieve, so subsequent choices stay focused and practical. You now translate the chosen approach into a concrete plan. Write tight pseudocode for the core routine and highlight invariants that must hold. Once the logic is stable, implement incrementally, first a correct but simple version, then optimize hotspots. Use unit tests and small randomized stress tests to compare outputs against a brute force baseline. This finds subtle bugs quickly. If performance is an issue, profile to locate bottlenecks and refactor that inner loop or data structure with targeted changes. You finish by running comprehensive tests and timing the solution against the required limits. Make sure memory stays within bounds. If results pass, clean code and add comments that explain tricky steps and invariants. When things go wrong, isolate the failure, reduce to a minimal reproducible input, and use binary search across changes to find where behavior diverged. As a key tip, check off by one and integer overflow first. They are common culprits that appear as mysterious failures.
Thanks for watching. Consider subscribing if we helped you.